All right, welcome everybody. We're back here. It is Tuesday night, 8:30 p.m. here where I live in the U.S. And tonight we're going to talk about 5 common types of exam topics you're going to see. You see, right now in the U.S., this Thursday, that'll be Thanksgiving for us. And Thanksgiving is kind of this holiday where we all get together with our families and eat big meals, watch American football, and just kind of a nice day off from work and school and so on. But it's also the time of the year that you start to feel like this semester has kind of gotten far along. We're kind of getting into the semester, and final exams aren't terribly far off. So these 5 topics we're going to talk about, hopefully that's going to get you ready for these exams at 3 or 4 weeks off, depending where you go to school. We're going to talk about it in the context of this idea called cognitive load theory, which is a way to help you think about your thinking and think about your studying. So let's do that. Let's see what we can do here. Jump over here. There we are. There it is. And let me pull the chat up here. And I can see some people here. Thought, good morning there to you. It's actually evening here. And Fasu, welcome. And Loretta's here. Excellent. Good to see you, Loretta. I hope you're ready for a good Thanksgiving down there in Texas. All right, so cognitive load theory. It's this idea that you can only process so much information at one time. So your brain can really only process a certain amount coming into of sensory information coming in. And if it's too much, you start kind of forgetting things or you start missing things. So this is a model that there's a link in the description of this video. So it's real helpful as a student to think about your learning. It's called metacognition, kind of looking at your overall cognition or thinking. Hello, Nishit, good to see you. So think of it this way. You have information coming in, like your teacher or a book, and it's either written or spoken, visual. So you have all this sensory information, and if you don't do anything, it's gone. You're going to forget it. It'll just be forgotten. So if you get it into working memory, which is kind of like short-term memory, then you can rehearse it. So you can repeat it to yourself, or you can take notes. That's a way you rehearse information. You can have the teacher, if a good teacher will kind of go over it several times, so you keep kind of rehearsing it. And if you're lucky, it'll be encoded into your long-term memory. And that's what we're really trying to do, is get things into long-term memory. Hey, Rotrex, welcome. Good morning. It's everybody. It's morning for most people. It looks here. It's evening here. It's dark. So we get the information to long-term memory. Then we go in for an exam, for instance, and we try to retrieve it into working memory. Then we answer the question on the exam. So we want to encode it in a way that we can easily retrieve it. That's why practice tests are so good. You get to practice the retrieval. But the key idea is cognitive load says that you can only do a limited amount. So we have to be careful about what we focus on and not be distracted. So think about that as we do some chemistry tonight. So we're going to look at electron configurations, electronegativity, balancing equations, mainly that mole ratio, some mole stuff, and then naming. That's our goal. And if you can do these, you're going to be in good shape. You'll see all of those on your next exam probably. All right. Hey, Wesley, good to see you. So this is the thing that for me as a chemistry student, when I learned this, I was like really excited. So you've got the periodic table here. And so you can see all the elements. So I'm going to remove those. And this is what you should remember. And there's a link in the description that goes over how to do this in some practice. So don't get too caught on it now. You can go back and watch that. But if you remember the blocks, here, the orbital configuration blocks, everything gets kind of easy. All of these, they end in S1. All of these end in S2. And then we got 3D, 1 all the way up to 10. Remember the d orbital holds up to 10. That's why there's 10 spots here. And then you have your P's, P1 to P6. 1, 2, 3, 4, 5, 6. P only holds 6. So I can circle any element here, and I can tell you what it ends in. So this one here ends in 3p, 1, 2, 3, 4, 5. 3p5. And if you look at it, chlorine ends in 3p5. Below it, bromine's 4p5, 5p5. So that's the easy way to tell all of this. Hello, Diaz. And I'm right, you're wrong is here just out of boredom. Well, I'll try to deliver on that. So give this one a try. See if I give you, let's say, how about phosphorus? Right there, phosphorus. This one right here. What does it end in? Oops, I'm gonna mess you up there. What is the last term of the electron configuration of phosphorus? High school analytical chemistry. Analytical chemistry, that's what I did a whole bunch of. I'll see if I can do some videos there for that Diaz. All right, anybody figure out phosphorus? If you write the whole configuration, it should end in, so it's 3p1, 2, 3. It'll end in 3p3. And then you can do the rest, 1s1, 1s2, 2s1, 2s2, 2p, 1, 2, 3, 4, 5, 6, and 3s2. Oops. And that's when we end in that 3p3 there, so 3s2. So that's how you do it, 3p3. You got it, Ban Jiangshen. So if you need to know this, if you need some more help, look in the description. There's a great video on that. This is a key skill. So if you get this, your cognitive load on the test, you won't have to think of all this. You can just look and remember that third period, 1, 2, 3, 3p3. All right. Let's look at electronegativity real quick here. So this is the trend you need to know. And electronegativity is huge because it's, if you look at bonding, if you look at reactivity, you look at polar, nonpolar, you got to know this. The key to knowing this, fluorine is the most. So any direction you go away from fluorine, it's going to become less electronegative. That's the trend. So if you remember that trend, you'll know that when you have two atoms, the more electronegative will pull those electrons more. Hello, Guilty Sa. I'm actually working on a big set of guides and stuff on oxidation and reduction, so I'll hopefully share that soon. So when we talked about this here with electronegativity, here's your oxygen and here is your hydrogen. We talked about water before. What it meant is because fluorine's here and then hydrogen's way over here, or I should say oxygen's right here. Oxygen's going to have these electrons more. It becomes more negative. This becomes more positive. That's your polar molecule. So learn this trend for electronegativity. There's a link in the description of this all about it. Make sure you know that for your tests. Oh, I want to show you a quick demo here. So you remember last week we floated a paper clip on water to show hydrogen bonding. So I've left the paper clip here and it's still, my camera's flipping out. It's still floating on water. There's one at the bottom too, you see, but the one on the top, it's still floating. It's not rusting or doing anything. My camera's just spazzing out here. So I thought that was pretty cool. And that's the hydrogen bonding. Those water molecules, they form that hydrogen bond there. All right. How are we doing here? So I'm right, you're wrong. Have I bored you yet? Taylor, great. Thank you very much. All right, so let's do this one. The one I want to show you here is not so much balancing. I think you guys know how to balance equations. Looks like 2 chlorines and just 1. So let's put a 2 here and 2 sodiums, 2 here. Hello, Anukrika. I'm trying my hardest. Good to see you. So here's what I want you to know about this, is that these coefficients here, 2, 1, 2, we think of that as the mole ratio, right? That that is so important. That's the whole reason we balance equations, really, is to get the ratio. So if your teacher, you're on an exam, you were given something like 1.7 moles of sodium and asked how many moles of chlorine would you need for the reaction to go to completion, just set up a ratio. 1.7 times 1, so I'm going to cross multiply, equals 2 times x, 2x, divide both sides by 2, and you would get, oh goodness, that's hard. Oh, what is that? You would get something. My brain is broken here. So you could figure out the moles really easily when you do that. So give this a try here. Let me set this up. Use that ratio. And let's say you're given, let's make it even, let's make it even easier. 2.4 moles of chlorine gas. 8.5, thank you, Wesley. Know what happened there. Cognitive load. You know, when you're doing streaming, you have this cognitive load problem because you're trying to talk, you're trying to write and move through all these different screens, look at the comments, and sometimes your brain just can't handle it. And a simple math becomes difficult. And so, you know, when you're taking an exam or you're studying, you want to minimize all the distractions or make things so automatic that you don't even need to look them up. And that will help you do much better on exams. So try this one. You got 2.4 moles of this chlorine gas. How many moles of sodium chloride would it produce? This is one of those ones that they always like to put on tests. You'll always see this on a final exam for chemistry. So it's just a ratio, right? You can kind of see too that it goes from 1 is doubled. So you could even just double this to get your answer, or you could cross multiply. So x equals 2 times 2.4. I can do that, 4.8 moles. So remember, these coefficients, that's the ratio. In this case, we would say that we have an excess of sodium, so we would consider this to be the limiting compound here. Usually with these stoichiometry problems, they'll give you this and say you have this in excess. So you have more than enough, then you can just ignore it. That's typically the way that works. 2.4 times 2, you got it, Guilty Sa. You would be surprised how many students don't realize that the coefficients just give you the ratio. That's really why we balance. Like a lot of students do not know that or don't think of it that way. All right. So I'm not going to do a lot of moles to grams problems because they do get kind of boring to watch me do. I watched a video where I was doing mole to gram problems and I kind of got bored watching myself do it. So that's not a good sign. But I do want to show you this. So this is called the mole map. And your teacher might have shown you this. They might not have. But if you think of the mole as the unit that we use to transfer between other units, it gets kind of easy. So if you're given grams, you're going to divide by the molar mass. In fact, if you're given liters, you would divide by this constant here. And here, you would, if you're going from, say, particles like molecules or atoms, you would divide by Avogadro's number. So you always divide to get to the mole. And from the mole, you always multiply. And we said that last time, multiply to help remember. But the key is if you got something like grams and you want how many molecules you have, you've got to go to moles and then go to molecules. Can't we use the product method? You could. You can use any method that you want to use for these things. It's good to know a few methods and really to deeply understand underneath why they work. But as long as you get the answer, most teachers are okay. So yeah, so here, how about this? If you were given 3.4 grams of H2O, how would you get to molecules? So you don't need to do the math, but how do you get to molecules? Think about that. I can't even draw a question mark tonight. Wow. How would you get to molecules from grams? That's the question. And Huang, I would agree that 22.4 is only for ideal gases. Typically at the general chemistry level, you'll be given ideal gases at standard temperature and pressure, the normal condition. Shane, you know, everybody has had professors that are, you're asking what could be done about a terrible professor. We've all had terrible professors. Sometimes at the university level, they're really good researchers. They just can't teach very well. The best thing to do is to try to figure out why they're doing that, what their goal is, and just learn their tricks. It's hard. It makes it really hard. It makes it kind of unenjoyable. And then the next semester, hopefully, you get someone you enjoy getting chemistry from. That's my only advice. It's a challenging situation. Wesley, you're saying you get your moles, you get your grams, get them to moles, and then you go to particles. So grams, we would divide by the molar mass of water, which we'd find from the periodic table, and then you'd multiply by Avogadro's number, and that would give you particles. So there's another video on how to use this in the description, but when you're thinking about stoichiometry, make sure you understand how these are all kind of related. So this maybe would help you do that. All right. So we're getting kind of cruising through this tonight. What time is it? 8:47. Maybe do another 5-10 minutes and call it good. How about this? Naming compounds. We did this a little bit before, but I want to show you this method. Again, we're talking about how do you lower the stress on your brain of the things you have to recall and the things you have to do. So a lot of the kind of tips and tricks and things, one of the reasons they're effective is they help lower all of the things your brain has to do. It gives your brain a break to focus on other stuff. So let's name a few compounds with one of my favorite things, the crisscross method. So put the trend for ionic charge, which actually is another thing in terms of cognitive load, making your brain easier, make it easier for you to do tests and work. All of these are 1+, all of these are 2+. These are positive, but their charges vary. 3+, and then we go, carbon really doesn't often get a charge. We put 4+ there, go down, 3-, 2-, 1-, and 0. Good trend to know. So how do you write the formula for aluminum oxide? So I should have called this formula writing. So how are you going to do that? All right, here's the crisscross method. Aluminum's right about here. So it's going to be 3+, and oxygen, I would remember oxygen is 2-. I've just memorized that one. Yeah, Wesley, the carbon really does not form ionic compounds very often. It's mostly covalent, and then we don't really worry about charge. So the reason they put the 4+ or 4- here is just to help you remember the trend. In practice, carbon doesn't really form a lot of ions. It's usually covalent. So good question. All right, so here's the crisscross method. I'm going to write aluminum, and then I'm going to write oxygen. I'm going to write my 3+ and my 2+, and then I just crisscross them. That's it. That's the formula for aluminum oxide. So close, Al2O is close, but make sure you have the charges balanced. So if aluminum's 3+, 2 times 3+ is 6+, 3 times 2- is 6-. So these charges cancel out. So that's the correct formula there. So if you had Al, just AlO2, Since oxygen's -2, this side would be -4, and this side would be +3. So that won't work. All right. And I have a whole video on the crisscross method in the description if you would like to spend some more time with it. It's effective. There, you got it, Guilty Saw. You got it now. Let's do another one. Why don't you guys do this one? Calcium nitride. Give ourselves some room here. And calcium's right about here, and nitrogen's, I think it's right under the 3. So this is your nitrogen, and this is your calcium. Take a second, see if you can get that. And note that the charge, that negative sign, comes after the number for ionic charge. It goes right after it. So we just crisscross them, and Ca3, N2. Not too bad, right? Let's shrink this. We'll do 2 more, and I think that's probably about all for this evening. Magnesium, I think it's right here, and you remember oxygen's over here. I'm right, you're wrong. You got it. Excellent. Calcium nitride. And so one of the things you can help yourself do is, practice is key. One of the things you can do is, if you memorize some of these real common ones like nitrogen and oxygen, if you remember their charges, that makes it a lot easier for you during the exam, because you don't even have to look it up. It's just boom. You don't even think about it. So magnesium oxide's a little bit weird. I'm wondering if anybody's going to get that one correct. I'm right, you're wrong, got it correct. Because you could, if you crisscross it, you could move the 2 here and the 2 here. But when we have the same number there, we actually reduce that down to 1. So, and we don't really write the 1, right? So that would just be MgO. So if you have the same number, make sure you reduce it to simplest terms. All right, I'm going to give you one more right here and see if you can do sulfur dioxide. This is a trick, incidentally. Shane, you were talking about being a tricky professor, so I'm telling you this is a trick here for you. Yeah, I think you would say like reduces to the lowest form. That's what we would go at. And Guilty Sal, you got it, MgO. Good job. Excellent. So you're getting better at this. All right. So here is the trick, right? Sulfur and oxygen are both nonmetals. So since they're both over here on this side, for nonmetals, we don't worry about charge. And the key is they have di in here. So if you see di or tri or mono, you don't need to worry about charge. Sulfur, di means 2, dioxide. So that's it for that. So be cautious. Let me jump over to my website here. See if I can find it. And I'll pull something up for you that you might find useful if you're trying to learn naming. Go to Breslin. That's me, Breslin, BRESLYN.org. And if you go to my website, breslin.org, daily dose of memes. Nice. SO2. Make sure you make it a capital O for oxygen. If you go to the naming and formula writing here, you prefer small o. Okay. If you go here and say click into formula writing for simple ionic compounds, there's some videos, and if you practice here, you can like put something in like, what is this? Sodium nitride, Na3N, I believe. Yeah, and it tells me I'm right, and it can give me a new problem. So this is freely available. Aluminum sulfide, Al2S3. Once I get started, I enjoy doing this for some reason, which is a little bit odd. Anyway, so you can go over to breslin.org, and I'll just type that in the chat. And I built this thing, I must have built this 5 or 6 years ago. So the first time I really programmed a computer for my students. And it's kind of nice. And there's all the stuff that you need on that there. I think that we're going to wrap up here. It's about 25 minutes. I hope this has been useful to everyone. A question, is the U.S. the only place that does Thanksgiving as a holiday? I'd be curious to hear if anyone in another country does Thanksgiving. I think it's just the U.S. I know how to code a little bit now, daily dose of memes. But, you know, Chat GPT and stuff, it does help you spot your errors when you're coding. So it's kind of a different, it's a different world out there now. I would code and have one small error and spend hours finding it. Now I can just put my code in and say what's wrong, and it often will tell me. All right, Canada. Yeah, I don't think Canada does Thanksgiving. I'm not sure. All right. Well, that's it. I'm going to go to bed here. It's late. You know, it's not that late. It's getting towards 9. I'm going to head towards bed, and I will be back next Tuesday. And you can find all my stuff over on my website, breslin.org, or punch cards. Or you can go to my YouTube channel. I've not used punch cards, but I used a TRS-80 when I was a kid. So yeah, coding can be stressful, but it's changing. The world's changing with coding. A lot of these AIs can it's kind of shifting it a little bit. I don't know how much it will. You'll still need people who can think really clearly, but yeah, anyways. All right, everybody. It is great spending time with you, and I will talk to you next Tuesday. This is Dr. B, and as always, thanks for watching.